Right now, at this exact second, your brain is actively destroying memories.
Yep, it really is.
Like, by the time this deep dive is over, it will have permanently deleted thoughts you had this morning.
Gone forever.
While, physically burning entirely new pathways to remember other things. It's crazy. Welcome to the show, everyone.
Glad to be here.
Today, we're taking a look at a really fascinating summary of the 8 brain rules from the YouTube channel Bookpedia.
Right, and we're not just doing generic self-help today.
Exactly. We are tearing into the biological mechanics of how your mind actually works.
Because the mission here is to translate those deep neuroscience secrets into actionable daily habits for you.
Especially if you're a student buckling under heavy academic pressure, or a young adult navigating the absolute minefield of social anxiety.
Or even a young professional just trying to find your footing in a really high-pressure workforce.
Because what is absolutely crucial to understand right out of the gate is this feeling overwhelmed or constantly exhausted isn't a personal failure.
It's really not. I mean, it's a biological mismatch.
Right.
If you're struggling, it's highly likely you're simply playing against your brain's natural operating system.
So today is all about understanding the hardware so you can finally rewrite the software.
I love that framing.
Okay, let's unpack that hardware then. Because we constantly hear that we need a strong physical foundation.
Which usually means sleep.
Right, specifically sleep. But we treat sleep like a luxury or just some passive state where we turn off for 8 hours.
Which is a massive underestimation of what's actually happening.
So what is the biological reality of sleep?
It's essentially a massive biological power wash.
A power wash.
Yeah, I mean, we tend to view sleep as this state of total inactivity. But the science highlighted in our source shows your brain is arguably busier when you're asleep than awake.
Wait, busier? How is that even possible?
Well, during deep sleep, this mechanism called the glymphatic system kicks into high gear.
Okay.
Your brain cells actually shrink by up to 60%.
Whoa, 60%?
Yeah. And that allows cerebrospinal fluid to just rush through the brain tissue.
Oh, I see.
It physically flushes out neurotoxins, specifically these things called amyloid beta plaques that build up during your waking hours.
So when a student pulls an all-nighter to cram for an exam.
Or a young professional is burning the midnight oil to impress a new boss.
Right. They aren't just, tired the next day. Their brain is literally stewing in its own metabolic waste.
Exactly. That cognitive fog you feel. That is the physical presence of uncleared toxins.
Because your brain couldn't run the wash cycle.
Precisely.
Sleep.
And furthermore, sleep is when memory consolidation happens.
Which means?
The hippocampus replays the day's events and transfers them to the neocortex for long-term storage.
So if you skip sleep, you skip the save process.
You lose the beta.
But logically, I need to push back on this a little.
Sure, go ahead.
Because we see this massive rise in revenge bedtime procrastination.
Oh, absolutely.
Let's say I've been in high-pressure meetings all day, my brain is fried, and I finally get into bed.
And you just want to unwind.
Right. Doom scrolling reels or watching videos feels like a way to dump all that excess adrenaline.
It feels like you're reclaiming your time.
Exactly.
Huh.
I feel like I'm relaxing. Why does the brain interpret staring at a screen as overheating rather than winding down?
It's a great question, and it really comes down to evolutionary biology.
How so?
Well, your brain doesn't know what a smartphone is.
Fair point.
When you stare at a screen in the dark, the blue light hits your retina and sends a direct signal to the suprachiasmatic nucleus,
Which is?
your brain's master clock. And that signal says, hey, it is high noon, the sun is blazing, stay alert.
Oh, wow.
So it immediately suppresses the release of melatonin, which is the hormone that initiates sleep.
So my conscious mind feels like it's relaxing because I'm entertained.
But your nervous system is being artificially held in a state of hyperarousal.
That is wild.
It is. You're giving your brain rapid-fire dopamine hits with every swipe.
Keeping the stress response active.
Right. While simultaneously denying the glymphatic system the chance to actually clean up.
So prioritizing sleep isn't just about feeling rested.
No, it is a profound daily exercise in self-love. You have to actively decide to stop stealing from your own cognitive future.
Which naturally leads to how we stimulate that brain once it is fully clean and awake.
The second rule.
Right, rule 2. We always hear about exercise. Go for a walk, hit the gym.
Standard advice.
But let's get past the generic stuff. If I'm sitting at my desk, completely paralyzed by academic panic or social anxiety about a presentation.
Yeah, that frozen feeling.
Exactly. How does moving my legs actually fix up a problem in my prefrontal cortex?
Well, it's not just about getting blood flowing, though. I mean, that helps.
Okay, what is it then?
The source points out that aerobic exercise, even just a brisk 20-minute walk, triggers the release of a protein called brain-derived neurotrophic factor, or BDNF.
BDNF, got it.
Think of BDNF as Miracle-Gro for your brain.
Miracle.
Yeah, it literally stimulates neuroplasticity, encouraging the growth of new neural connections.
And repairing failing ones, right.
Exactly, specifically in the hippocampus.
So it's not merely a temporary dopamine boost. Exercise is structurally altering the brain to be more resilient.
Yes, and regarding that feeling of paralysis or panic you mentioned.
The desk panic,
Right, we have to look at the relationship between the body and the amygdala.
our brain's threat detection center.
Exactly. When you're hit with a wave of social anxiety or academic overwhelm, your amygdala has hijacked your brain,
It's screaming that you're in physical danger.
which shuts down the prefrontal cortex, the logical, problem-solving part of your brain.
It's the classic fight or flight response, but triggered by an email instead of a predator.
That's spot on. And you cannot simply outthink a hijacked amygdala.
You can't just logic your way out of it.
No, you have to use the body to signal safety to the brain.
How does that work?
Moving your body rhythmically like walking acts as a physical grounding technique.
Okay, that makes sense.
It burns off the acute cortisol spike, lowers the heart rate, and tells the primitive brain, we are moving, we are not trapped, the threat is passing.
And then the prefrontal cortex comes back online.
Exactly. Once that physiological storm breaks.
That is incredibly actionable. So if you hit a wall, do not just sit there gripping your coffee mug trying to force your brain to work.
No, stand up, walk.
Change your physiological state to change your cognitive state.
Exactly.
But okay, let's say you've done that, you're rested, you've taken a walk, your logical brain is online.
You're ready to work.
Right, you sit back down at your desk, and now you have to face the absolute avalanche of notifications, multiple open tabs, a massive to-do list.
Rule 3, focus.
Yeah. How does the brain actually handle multitasking?
It doesn't.
It doesn't at all.
No, that is one of the most pervasive myths in modern work culture.
Really?
Yeah, the brain is physiologically incapable of focusing on two cognitively demanding tasks at the exact same time.
So what are we doing when we think we're multitasking?
What you are actually doing is rapid task switching.
Task switching.
Your brain is aggressively shifting its spotlight of attention back and forth every few seconds.
It's like constantly changing the channel on a TV, but expecting to follow the plot of 5 different movies perfectly.
That's exactly what it is. And there is a massive metabolic cost to that.
A metabolic cost.
Yeah, every time you switch from writing an essay to checking a text message and then back to the essay.
Your brain has to completely reconfigure its neural networks.
Exactly. This is called the switch cost. It burns through oxygenated glucose in the brain at an alarming rate.
Oh, wow. So that is why you can sit at a desk for 8 hours, rapidly bouncing between emails, Slack messages, and a project,
And feel entirely depleted by 5 p.m.
despite having accomplished almost no deep, meaningful work.
Exactly. Shallow thinking leads to short attention, and short attention leads to short success.
That really hits hard for young professionals who feel like their boss expects immediate replies to everything, while also demanding high-level strategic work.
It's an impossible biological ask.
So what's the actionable habit here?
To commit 100% to a single task for a designated window of time.
Deep work.
Deep work is a quiet, centered superpower in a distracted world. You have to consciously train your mind to tolerate the boredom of a single focus.
Because it will feel uncomfortable at first.
Oh, very.
Yeah.
Your brain is addicted to the cheap dopamine of novel distractions.
But sitting through that discomfort is how you enter a flow state.
Precisely.
Let's talk about that discomfort, though, which ties into Rule 4.
Stress.
Right. Stepping into that deep work can be terrifying if your baseline is anxious. The source is very clear that we have to manage stress before it manages us.
It's critical.
But for someone dealing with chronic imposter syndrome at a new job, where they overthink every word they say in a meeting,
Yeah, the internal spiral.
exactly, how do we biologically manage that stress response?
First, we have to reframe what stress actually is. We view it as an enemy, a personal failing.
Right.
But biologically, stress is just data. It's a dashboard warning light. The release of cortisol and adrenaline is your body's way of saying, hey, the demands of our environment currently exceed our perceived resources to handle them.
So it's not a malfunction, it's an alarm system working perfectly. We just don't know how to turn the alarm off.
Precisely. And the source provides 3 specific actionable grounding exercises to manage this.
tailored perfectly for that young professional panicking in the boardroom.
Exactly. The first is to pause and breathe.
Just breathe.
Well, specifically when the panic hits, you have to activate the parasympathetic nervous system, the rest and digest mode.
Yeah.
Deep, slow, diaphragmatic breathing physically stimulates the vagus nerve.
Which does what?
It acts like a brake pedal on your heart rate and your cortisol production.
So you are literally hacking your own nervous system to force a calm state.
Yes.
That's amazing. What's the second step?
The second step is movement, which we've already discussed,
Yeah.
using the body to process and release the physical tension of those stress hormones.
The physical grounding technique.
Right. But the third step is arguably the most important for imposter syndrome,
Which is?
resetting your expectations.
Unpack that. How is resetting expectations a biological tool?
Because perfectionism keeps the brain in a chronic state of threat.
Oh, I see.
If your internal rule is, I must never make a mistake or I will be exposed as a fraud, your amygdala is constantly on high alert.
Scanning for failure.
Exactly. You are bathing your brain in low-grade cortisol all day.
That sounds exhausting.
It is. Acknowledging your human limits, accepting that learning curves involve failure, is a profound act of self-love.
It signals safety to the brain.
It says mistakes are allowed here, which instantly lowers the baseline stress and actually improves cognitive performance.
You are not a machine. You are allowed to be human, and paradoxically, accepting that makes your brain work better.
Beautifully said.
Okay, so we've grounded the body, we've quieted the noise, and we've deactivated the threat response.
We are ready to learn.
Exactly. Rule 5 moves us into the actual mechanics of learning and absorbing in the world. The source talks heavily about repetition. Repeat to remember.
Right.
But why? What is physically happening when we repeat something?
This brings us to a fundamental rule of neurobiology, often summarized as Hebb's law.
Which is?
Neurons that fire together wire together.
Okay, explain that.
The first time you learn a new concept in college or try a new task at work, a weak temporary connection is formed between neurons.
Like a fragile little bridge.
Exactly.
Yeah.
And if you don't use it again, the brain prunes it away to save energy.
Think of it like hiking through an overgrown jungle. The first time you hack your way through, it is agonizingly slow.
The weeds are everywhere.
Right. But if you walk that exact same path every single day, you trample the weeds, you pack down the dirt, and eventually...
It becomes a paved superhighway.
Exactly.
That is an excellent way to visualize a biological process called myelination.
Myelinate.
Yeah. Every time you repeat a thought or an action, your brain wraps that specific neural pathway in a fatty substance called myelin.
What does the myelin do?
It acts like insulation on a copper wire. It prevents the electrical signal from leaking and allows it to travel up to 100 times faster.
100 times. Wow. So when we consume endless motivational content on our feeds...
And we feel inspired for 10 seconds and then swipe to the next video.
Right. We aren't building a superhighway. We're just taking one step into the jungle and then turning around.
Exactly. We seek inspiration, but we lack integration.
That's a great way to put it.
The source points out that to overcome deep-seated self-doubt or to master a skill, repetition is non-negotiable.
You have to repeat your goals, your values, and your learning materials daily.
It will feel tedious, but you are literally building the physical architecture of your subconscious mind.
And how we feed that architecture matters, which brings us to Rule 6. Visuals beat text.
Yes.
Why is reading a block of text so much harder on the brain than looking at an image?
It's purely a matter of evolutionary processing speed.
How so?
The brain decodes written words very, very slowly. Reading is a relatively recent human invention. We don't even have a single reading center in the brain.
Wait, really? We don't?
No. Instead, to read a dense academic textbook, your brain has to recruit multiple areas.
Like what?
Wernicke's area to comprehend the language, Broca's area to process it, the visual cortex to see the shapes of the letters.
It is incredibly resource intensive.
Extremely.
It's like trying to download a massive file on a 1990s dial-up modem.
Oh, perfect analogy.
You're forcing the brain to download one letter, one word, one abstract concept at a time.
But visuals. Visuals are a broadband fiber optic connection straight to the visual cortex.
A human brain processes images that much faster.
Incredibly fast. An image captures color, spatial relationships, and, most importantly, emotion in a fraction of a second.
It bypasses the slow, logical decoding process entirely. Which is why, for students drowning in academic pressure, staring at a wall of text for hours yields diminishing returns.
You have to ditch the endless paragraphs.
Map it out. Use color-coded notes, Draw diagrams, sketch the relationships between concepts, give your visual cortex something to latch onto.
And for goals, this is why vision boards actually work, right?
Yes. It's not just New Age manifestation.
No, it's anchoring a goal in the visual cortex.
Precisely. When the pressure peaks and your willpower is fading, a visual instantly reminds the brain of the destination.
Which creates a perfect bridge to Rule 7.
Emotions drive action.
Right. Logic might plan your study schedule, but emotion is the fuel that actually gets you to execute it.
Because discipline and willpower are finite resources.
Highly finite.
If your internal monologue is just, I must not be lazy, I have to grind through this, you are relying solely on the prefrontal cortex to force compliance.
As we discussed, the prefrontal cortex burns out quickly.
So what's the alternative?
Emotion taps into deeper, older parts of the brain, including the dopaminergic reward pathways.
Okay, give me an example.
Why does an artist spend a month meticulously painting? Why does a parent stay up all night with a sick child?
It's not forced discipline.
No, it's a deep emotional drive. The source advises that to sustain motivation in a tough job or a difficult degree, you must attach a story or a deep feeling to your daily tasks.
So if I'm dreading a massive data entry project at work, I shouldn't just tell myself, do this so you don't get fired.
Right, because that's a threat. That triggers the amygdala.
I need to attach it to a feeling of pride in mastering a tedious skill, or maybe the love for my family that the paycheck supports.
Exactly. You intentionally link the mechanical task to an emotional core to trigger dopamine.
And when you involve the emotional centers of the brain, the mind naturally aligns.
The work shifts from a mechanical chore to a meaningful pursuit.
I love that. But even with deep emotional drive, even with perfect sleep and sharp focus, you were still bound by biology.
You will eventually hit a wall.
Which brings us to the final rule. Rule 8. The brain needs breaks.
It really does.
And this rule completely shatters that toxic hustle culture myth of the non-stop 12-hour grind.
Oh, absolutely.
We're taught that if we want to succeed, we have to operate like machines, push through the fatigue. But what does the science actually say about our operational limits?
The science introduces the concept of ultradian rhythms.
Ultradian rhythms, what are those?
Just as we have a circadian rhythm that governs our 24-hour sleep-wake cycle, our waking hours are broken down into smaller cycles.
Okay.
The human brain is biologically designed to operate at peak focus for about 90 to 120 minutes.
And after that?
After that, it hits a physiological limit.
What's happening at that limit? Are we just out of glucose?
It's a combination of factors, actually. It includes the depletion of neurotransmitters and the buildup of a chemical called adenosine.
Adenosine.
Yeah, creates sleep pressure and brain fog.
So if you try to push past that 120-minute limit, say studying for finals or rushing a presentation,
You drop into a biological trough.
you might still be staring at the screen, but your error rate skyrockets.
Your comprehension plummets and your creativity flatlines.
Yet, in a high-pressure situation, taking a break feels like weakness. We feel guilty. We think, if I stop now, I'm going to fail.
It's a terrible mindset.
How do we overcome that guilt?
By understanding that a break is not a cessation of productivity, it is a requirement for it.
A requirement.
Yes. Taking a 5 to 10 minute break allows the brain to clear adenosine and replenish glucose. But, and this is a big but, we have to be very clear about what a break actually is.
Right. Picking up your phone to scroll through social media is not a break.
No, it is definitely not.
Why not?
Because scrolling is just task switching. You are still bombarding the visual cortex and the prefrontal cortex with novel information.
So a true biological break involves a state change.
Exactly. Closing your eyes, sitting in silence, looking out a window at a distant horizon to relax the optic nerve.
Doing a brief breathing exercise.
Right. When you do this without guilt, knowing you are actively servicing your mental engine, you bounce back with double the clarity.
You are respecting the machine.
Exactly.
So synthesizing everything we've talked about today, from the biological power wash of sleep to the miracle grow of exercise,
The metabolic cost of multitasking.
grounding the amygdala, myelination, visual processing, emotional dopamine, and respecting our ultradian rhythms.
It's a lot.
It is. But what we are really talking about is a fundamental shift in how we treat ourselves.
I completely agree.
True productivity isn't about ignoring your biology to be a machine. It's about working in harmony with your deeply human design.
Exactly. You cannot fight your own biology and expect to win long term.
No, you can't.
But I want to leave you with one final provocative thought that takes all of this a step further.
Oh, I'm ready. Lay it on me.
We've spent this entire time talking about how to master the rules of your brain, right?
Right there.
But Emerging research into the human microbiome suggests a radical twist.
Microbiome, the gut.
Yes. The enteric nervous system in your gut contains over 100 million neurons.
100 million.
And it produces about 95% of your body's serotonin.
Wait, so our gut is producing the chemicals that govern our mood and focus?
Yes. There's a constant two-way communication highway between your gut and your brain via the vagus nerve.
That is mind-blowing.
So as you go out and try to apply these 8 brain rules, consider this.
Yeah.
What if your brain isn't even the ultimate boss?
Oh, wow.
What if the food you eat and the bacteria in your stomach are actually sending the signals that dictate these rules in the first place?
Who is really in charge of your mind?
Exactly.
Now that is something to chew on, literally and figuratively.
Absolutely.
We will definitely be diving into the gut-brain connection in a future deep dive.
I can't wait.
But for now, the ball is in your court. Action is what turns neuroscience into power. Will you continue to let your environment dictate your limits, or will you start working with your biology today?
The choice is yours.
If you found value in this deep dive and want to keep leveling up your understanding of how you work, don't let the journey stop here. Drop a comment below and let us know which of these brain rules challenged your current habits the most.
We'd love to read them.
Hit that like button, share this with a classmate or a coworker who is feeling the burnout, and make sure to subscribe so you never miss out on our next deep dive. Remember, we all have the exact same 24 hours, but your mind is your greatest asset. You just have to know the biology to unlock it. See you next time.